Welcome back. In this video, I'm going to be showcasing a data compare function and showing some different ways of doing it, as well as discussing some of the issues with it. Since this is just a prototype, there are several problems with it that I can address fairly easily, but just for the sake of this prototype and keeping it simple, I am doing it fairly, I don't know, it doesn't have a lot of data verification, so it kind of is sloppy and can have incorrect outputs at times, and I'll talk about exactly when those outputs can be incorrect and how that happens. So what I have in front of me is two chickens. Now these chickens are being compared on their health. Currently their health is the same. If I go ahead and slap one and run it again, we have a false, and we would do it again, we have a true. If I go ahead and heal them both, we then get another true. So this is fairly simple. Let's go ahead and take a look at a different version of this, because I am showcasing a longer version, and I'm going to showcase the simple version, then cut off that bit of the video, and then I will discuss some more about it. So I have compare simple and then compare compact. Let's go ahead and teleport these chickens to me, and then let's do compare simple. Now what I'm doing here is, as you can see, it returned true. Now what I'm comparing here is an array. That array is their position values. So I can compare strings, arrays, integers, floats, long, short values, pretty much anything. Anything that's data can be verified and compared. So what we have here is just two chickens that we're comparing off of. So let's take a look at the actual commands. As I said, this is the simplified version. What we have here is one command that will make the storage, which is just an armor stand with a storage tag in its head item. It's usually what I use for storage. Now, after that, we're running check simple, which is a data modify. What we're taking is we have two tags on two entities. We have a compare A tag for one entity and then a compare B tag for the second entity. We have one tag on each entity we want to compare with, and then we run the command. What we're doing is we are taking that information and placing it on a storage.check string. Now this string can hold any type of information because it's not been previously set to hold a specific type, so we can set it to be anything. And what we're doing after that is a little bit of a weird logic. What we're doing is we're executing the success of this next command in the disabled slots for the armor stand. Now this is just so I can have a binary 1-0 output without using scoreboards. This is something I usually use whenever I'm trying to avoid using scoreboards, and those are other values I can take advantage of, but disabled slots for armor stands is a very convenient one. What we're doing is then we are doing that same copy, but instead from compare A, we are doing it from compare B. Now, how this compares is if the data in the A string is the same as the data in the B string, this will fail because it cannot properly copy over the information because the information is already there. But if the information is different, then it will succeed because it can override that data. Now this does cause an issue where if we look at this readout function here, 0 is true and 1 is false. Now the problems with this is that invalid data can read as true, meaning if only one entity has that specific string that I'm inquiring for, it can return as true when in fact there is no data there at all. Now this can very easily solve with a set of data verification and also a buffer entity, but since I am reading directly off of the entities, this is rather hard-coded. So usually the stuff that I'm pulling, as you can see if I go check simple here, I am pulling from a static set of data that I know the entity will have. But if I am to modularize this a lot more, it will be much different. Now, if you're looking at this and think that this can be simplified a lot, let's go backwards from there. So this is the conclusion of the discussion of the comparison logic, and now we're going to talk about modularization of data packs and functions in general. Now this isn't the best example of modularization, but I feel it's good enough because I have 3 examples of varying levels of modularization for this function set. Let's actually start here, and then I will work backwards to the simplest version. So this right here is the compare base. This runs 18 commands. Compare simple runs 12 commands. And then compare compact uses 6. We'll get to compact last. What we have here is the same function we used to open it, which is just that armor stand summoning command. And then we are running the compare sub check. Check right here is a set of 3 more functions and a kill command that kills the armor stand once we're done with it. We are then copying that information into storage A and B from entity A and B. This is just to hold it for the next one, because after we do that copy, we then do a test. And what we're doing here is we are placing that information from the storage A tag and placing it into storage V, and then we're doing that same thing I discussed earlier to place the B data into V. So that is the same logic, just applied to a different tag that's being copied from within the entity instead of from outside entities. And this allows for modularization a little bit later with it, because you can essentially, if you can modularize the copy command here, you can just run this test all the same. Then after that, what we're doing is we have a readout, which is I've already shown. And then, as I said, we kill the entity. Now, I've shown compare simple. As you can see, we are just doing the test function here, essentially. And then we're doing the readout, then we're killing the entity. This is basically what we did in the check function here. But instead, it's spread out, so it all is within that one command. Now, let's just kill all modularization at all. This is a one function set here. This will run everything in one function in 6 commands. This is the most efficient way of doing it, but it is rather compact and non-modular. So what we're doing is we're summoning that armor stand. This is the same command as before, but since I am doing everything in one function, I'm not calling the function that has this right here. Then what we're doing is we are executing as at E, and we are doing this right here every time we need to run something on this. Now this is where modularization is nice, because what I can do in the simple here is I'm executing as that entity, then running a function. Now everything within this function here that is being run under that condition as at E. But if I'm doing everything in one function, I have to continuously reiterate that I am executing as that armor stand. And I have to do that every time I run that. Essentially, all of these are just putting commands that are in other functions back into just a singular function. This does work. It functions the same as the rest, and it uses less commands, but as I said, it's non-modular. This is good if you need to just read one set of data in one instance, but not good if you want to be able to read a large set of data at any moment. Something I've been working on as of lately is data storage, modification, and verification. And this is just another step in that process. You've probably seen my null value detection, which is also going to be part of this. And upcoming is a memory storage system that has a seeker that seeks out the lowest possible position for a memory address. So all of this will be coming with time, because this is a fairly large project. It's kind of computer science, but it's computer science in Minecraft. So thanks for sticking around, and I will catch y'all next time.